Hey, it's W5HRO. Here's part 17. Here's the update for part 17. Brand new video here. I got lucky. Those last two resistors I had back ordered came in unexpectedly the day before last. I got the email notification. I'm like, what the heck's that? And they turned out to be those two resistors. I'd order them from two places, and the second place I ordered them from, they got them in way before the other one. The other ones won't be here until like April of 2021, and I'm not kidding. Those resistors are hard to come by right now for some reason. Everybody's sold out of them, it seems like. But let me plug in the power here. I've got the counter. If I can see what I'm doing here. Getting tangled up. I've got still kind of a mess here. But let me plug it up, and I also hooked up that NE555 timer board. See, it just came on. It's powering up, but it hasn't switched the relay yet. After 20 seconds, it's going to go click. So let's wait for it here, and the green light will come on. There. Now the primary winding, that Hammond 10 transformer, just got engaged. If I can get my finger out of the way of the phone camera here. But this thing, it's working good now. I've got a temporary PTT line here, so let me transmit. Look at that, 3880. Perfect, 3.880, my favorite frequency. And now this meter, like I mentioned in the last part 16 video, this meter's not going to read right because it's not this is not a 50 ohm output, and I've got that 17.5K resistor on there just to have the same thing that the RF deck's going to have in it. But it's showing over 100 watts now, and it's too high. It's only about 28, 25 watts max. The thing is, though, I've got this thing for some reason. This one supply. What I did was I completely rebuilt that board. I rebuilt that Zener board. I redid it, and because I changed a couple things. Right, I used 150 a volt stud mounted Zener, 10 watt Zener, and I used that minus 56 volt cathode K stud mounted Zener. So those two, I realized that minus 56 volt grid blocking line always needs to be on when you're not transmitting, and then so does the PTO. So I decided, let's make those two as reliable as possible, and those two are the first two that come up. So anyway, let me see here, but it's on now. And what was I going to look at? Yeah, the high voltage on the plate on this 6000 tube, it's come up to like 400 volts. It's creeped up on me from the last time. I changed these Zeners out. Maybe I should have left the ones I had in there. But what I was going to do is, let me see if it drops down when I transmit a little bit. It does, 388. It's still a little hot, and I've noticed if I'm really careful here, I got to make sure I don't apply 400 volts to my finger. No, they're not getting very hot anymore. But I think these Zeners aren't as their tolerance. They're not as accurate as the last ones I had on there. But it's not that big a deal. It's just going to give me more power out of the exciter, which is what's it going to hurt, right? But everything else seems to be okay. I've got 280. That's 280 now. It's because I'm not transmitting. It's going to be a little hot when it's not transmitting. 290 something. They're creeping up a little bit. 153, they creep up, but that's okay. I mean, once these caps stabilize, I'm trying to see, they don't feel like these are getting a little warm. I replaced this cap, and these two caps, and I replaced all the Zeners. Every one of them's new. But what I'm thinking is, I'm going to see how this holds up. And if something was to crap out on this thing before it's over, I could have to wind up removing these 5 watt Zeners and putting stud mounted Zeners all the way across the rest of it. I just drill a few more holes and mount like 2 or 3 more of them and just do it. Well, the reason I didn't do that, I was going to do that originally, but the reason for it is I want to try to keep the power dissipation down. Plus, well, they don't make a 380 volt Zener. I have to have two Zeners in series. So I don't, these case mounted, stud mounted Zeners, you can't really connect them in series unless you put one of them on a heat sink and isolate that heat sink from ground. So it's not an easy task. It's not an easy thing to accomplish. So that's why I went that route instead. But I'm going to leave this thing on and just kind of see how it holds up. What I noticed is these transistors do not get hot at all. They just get a little tiny bit warm. The heat sinks are what get warm. So it's working exactly like it's supposed to. These transistors, these NTE62s, are transferring the heat to the metal heat sinks, and the packages are staying cool. Because see, now look, if I do this, if I look at my voltmeter and I touch, see this one here? See, there's like the 500 volts, and it turned out, see, that supply turned out hotter than I thought it was going to. Instead of being 460 volts to 430 volts, it's still staying almost 500 volts. The supply is running hot on me. So that's why it's hotter on the collectors. But that's why that's why that PNP I had in here originally and those BUX 48As crapped out. They couldn't handle the voltage. They were too weak, they were too low voltage of transistors. But it was all I could find at the time. These are fine. These are like 500 volts on each of them right now. Although when I transmit, that's probably going to back down some, right? I'll clip on this line here. If I can keep from moving the camera around too much, let me clip on the line that's going to the resistors, or it's going to the collectors. There's the line to the collectors right there. And see, that's 498 volts. Now when I transmit, it's probably going to drop down, right? Oh, it did. That's what I don't know what I was thinking. I have to put the low, because right now there's the 6,000 tube, and the multipliers aren't really drawing hardly any. They're not really drawing current. There's a grid voltage applied to them, but the current, I mean, there's no plate current because they're not engaged. I mean, they don't. That grid blocking supply keeps them not drawing current until it's grounded. So 4 see, it does drop down. It drops down to 416. Okay, so it's dropping down. So let's call it 420. So the supply does drop down when I'm transmitting. Cool, man. Now one more thing. I did order, and I'm getting ready to do this here next. I got some brand new tubes. 6AH6WAs. These are the military versions. And the 5749Ws. So these are GE jams. They're both sets are GEs, and I'm getting ready to change out these tubes in the PTO and this guy here. So let me do that, and let me turn this thing off, let the tubes cool down. I'll stop the video, and if it after it cools down, I'll plug the tubes, and if the power comes back up, I'll start the video up again. Okay, I got the new tubes put in. I've been playing with it, and the power actually went down a little bit, but that's okay. I think the tubes are drawing a little more current, but that's okay. They're heavier duty tubes and they're brand new. But it didn't change the frequency at all. It's still, my God, it's like 3880. I mean, it didn't even change. So what I'm going to do now is I'm going to put the bayonet shells on and check it one more time, and this thing's almost done, man. The only thing I haven't done is I got to hook up the current meter, that Heathkit meter, and figure out the shunting and everything. I was playing around with it last time, but it was pegging the meter out. I think because I had clip leads going down to the meter when I was testing it, and I think there's too much resistance in the clip leads. So anyway, but I drilled a hole, put a grommet, because there's going to be that switch on the front panel that switches the selector switch for the different current readings for the meter. So I got the hole there where I can run the wires down through and hook everything up. So anyway, we're almost done with this. I've just about got everything working, thank God, finally, after all these years. So we'll see. We'll see what happens here. I don't know if this is going to completely hold up. I know these will now. These don't get hot at all. These things, this is perfect. These NTE62s and this heat sink setup was the perfect situation. It was the perfect thing to do. And see, I've got the heat sinks insulated from ground, so they're isolated. So if they ever short out to the heat sinks, the cases do, it's going to keep working. It'll just make this live. So I probably should put a warning label on here somewhere saying beware, this could be hot. You know, if those mica insulators ever short out, but I doubt they ever will. It's probably never going to be an issue because I got the right transistors now. So let's keep working on this thing, and I'm going to keep plugging away, and I'm going to probably work on that meter tomorrow, try hooking it up, and it's getting close. And when I get it all working here, I'm going to shove it in the RF deck and see what happens to the grid drive, you know, see if it comes up to the 12 milliamps I need. I did hook up this one, I added the extra, this is an RCA jack. This is going to be, what's this for? This one here is going to be for the screen pot. I'm going to have that external screen pot, and I'm just going to have an RCA cable from the back of the RF deck to the back of here. It's just going to, you know, put the screen voltage down. It's going to run the screen voltage down through there to that big 5 meg pot if it works. But I'm going to wait. I'm going to wait to see if that works first. If not, then I'll just put a pot on the front panel of this thing and not worry about it. But the other one, this is going to come from the RF deck too. This one's going to come from that the bias switch on the front panel to go to the SB10 adapter. So when this one gets grounded, it's going to switch this other relay. And see, what I did was I just took the dielectric out of some RG8X coax, and I just wired it up. It's, you know, it's not shielded, and even the relays are not RF shielded, but it's really not much I can do about that right now. I had to figure out some way to get everything working like I wanted it to, and if there's some RF radiation from this and that, so what? It's not going to hurt anything. So anyway, but we'll keep plugging away here, and but I'm getting really excited now because I just about got this thing completely finished. This has literally taken me all summer long because I started out on this thing, and then I realized, you know, I kept buying a few parts, like a piece or two at a time, making sure it was going to work, trying it out, and instead of buying, I could have bought a whole bunch of stuff and just figured out what was going to work and what wasn't, had it done a long time ago, but I was trying to save money, and this thing still is this thing wasn't cheap to put together. These transformers, and plus, you know, I had to replace this big high voltage transformer once because of what happened, but that problem's solved now because I have it fused. And you know what too, when I plugged this thing in, the other transformer I had, that first Hammond 710, it used to buzz really bad, even when it wasn't even loaded down, and I think there could have been something wrong with it. There might have been a combination of, it might have been the PMP shorted plus the transformer was bad or something. Maybe I got a dud or something. But anyway, it looks like it's coming to life now, so now I just got to clean my mess up. I'm going to stop for the day because it's too hot. It's going to be probably 90, almost 100 degrees soon, so I'm going to stop what I'm doing and clean up my mess, and I'll start back on this thing first thing in the morning. I'm going to start hooking up that meter and stuff. So that's it for now. This exciter's almost ready to go. This is W5HR and an O.